equilibrium constant, as you can see there, the symbol is Kc, okay, and it gives the ratio between the product of the concentrations of products to the product of concentrations of reactants. Okay, so this is the first thing. It is a ratio. The second thing is solids and liquids won't form part of Kc. And the third thing, only changes in temperature can change Kc values. Okay. So no change in pressure, no change in concentration, and no catalyst can change the Kc value.
What's Kc?
Hmm?
What's Kc?
The equilibrium constant. You get me?
Yes, ma'am.
No changes in pressure or concentration or addition of a catalyst will change Kc. This word product means times or multiply. That word product is what is on the right hand side of the double arrow. This word product means times or multiply, and that is the reactants are the ones on the left hand side of the double arrow. So I want to do an hypothetical reaction. It is possible that you can be exposed to an hypothetic reaction. If you have reactant A and a reactant B making a reactant C and a product C and a product D, and the coefficients of A is little a, and B is little b, and C is little c, and D is little d. That, and then, the heat of the reaction is not important. And all these reagents are either a gas or a solution. A gas or a solution.
Can solutions go in the case?
Yes, because a solution's concentration can change. Okay? Then the Kc expression is the ratio between the product of the products. Please look before you write. The coefficient becomes the power of the concentration. Okay? So it's not just a simple, straightforward product. Over the product of the reactants and the coefficient becomes the power.
That's interesting.
C to the power of C. So is it like an elementary number?
I'm going to give it a concrete example now. So let's use my favorite, 3H plus, 3H2 and N2 going to 2NH3. This is a gas, that is a gas, this is a gas. Then the Kc value is, what is the product on the right hand side? NH3, so it is the concentration of NH3 to the power 2, okay, divided by the concentration of the hydrogen to the power 3 times the concentration of the nitrogen.
How do you calculate that?
We'll get there.
Like what goes in?
You could write it out, the concentration of nitrogen, ammonia times the concentration of ammonia, because it's the product of the concentrations divided by the concentration of hydrogen times the concentration of hydrogen times the concentration of hydrogen. So the mole ratio plays an important role, times the concentration of nitrogen. Square brackets in the Kc expression. Okay? But we shorthand the times the concentration of ammonia times the concentration of ammonia by saying concentration of ammonia squared. We shorthand it.
So if we don't use the square brackets, it's
You have to use the square brackets in the expression, otherwise it won't count.
then
But
how do you get to the answer?
I want to do that as
Ma'am?
soon as possible.
Do we have to use the square brackets?
It's on page 186, example 1.
Is there a unit or just that's the answer?
It's a ratio between concentration, so there's no unit. So we start off with hydrogen, which is a gas, and iodine, which is a gas in this reaction at 448 degrees. It's in equilibrium with 2 moles hydrogen iodide. And this is at 448 degrees Celsius. At equilibrium, we have how much hydrogen? 0.46 mole per cubic decimeter. And iodine, 0.39 mole per cubic decimeter. And our hydrogen iodide, 3 mole per cubic decimeter. Please follow my advice and answer the question like this, because it's a whole process of thinking that is going to bring you to the answer. So what is Kc? It is the concentration of hydrogen iodide to the power 2 divided by the concentration of hydrogen times the concentration of iodine. So that is your first mark. Second mark is now, if you substitute the concentrations and you want to put them in brackets, put them in round brackets, not in square brackets. Okay, because the square bracket has a meaning. So it is it is 3 squared, I don't need brackets for that, divided by 0.46 times 0.39. Watch it, Don't put those in square brackets. Okay, what is the answer?
50,17. 50,17.
And yeah,
Sorry. I wanted to ask, does it not have a unit because it's a ratio?
yes. Mole per cubic decimeter at the top, mole per cubic decimeter at the bottom. Okay, now, what is the meaning of the value 50.17? The meaning of the value is that this equilibrium lies to the right. And you can see that the hydrogen iodide has a higher concentration compared to the hydrogen and the nitrogen. So the meaning of this, nothing is favored, it's just the equilibrium lies to the right. It's not shifting because we're not changing anything.
How did we come to this conclusion?
Didn't you say
Because the value of Kc is much bigger than 1. The concentration of the product is much more
So less than 1 to the left.
than that of the reactants. So it is said that the equilibrium lies to the right, not the equilibrium shifts to the right. The shifting comes in with Le Chatelier's principle, where you change concentration or pressure or temperature or whatever, and there's a shift in the equilibrium. This is a reaction, and the Kc values meaning tells you that in that reaction chamber, most of it is Hi.
So ma'am, if we were to swap the product and also swap it with the reactants, would it then give us a different value?
Yes, let's do
So
that.
then the equilibrium. Okay.
Let's do that.
I'm confused what we last put.
So you've got 2xy, and they tell you that it's a solid. So that's a red light. It is in equilibrium with 2xy2 gas and y2 gas. Okay.
And then a question like this, why do we have a solid? Got it!
So what is given? It is in a volume of 2 cubic decimeter. And in a container and allowed to decompose at 400 degrees Celsius. Okay, we'll start this one again tomorrow. You've got 3 to do for homework.